Welcome to LIS754 Systems Analysis and Design, and in this session we are going to talk about the different types of systems architectures. There are primarily four types of architectures that we can talk about: hardware, software, application, and program. We are going to primarily talk about software and application architectures. We will look at a couple of examples of hardware architectures just because they're sort of interesting. And program architectures it's a very low level type of process by which someone will go and actually design the specific programs. And we will not spend any time really talking about that. That's more of a topic for computer science. When we're thinking about a systems architecture, there's a number of questions that we will need to think about and need to come to some level of decisions about before we can complete our design, our architecture. One is we need to know if there is an existing infrastructure for an organization, the organization in which we are developing our system, that we need to fit into. So if we're doing a transaction processing system in a bank, it's a high likelihood that there would be an architecture in which we would need to fit, or that there's that type of generic architecture that we talked about before, in which we would need to fit our system. In our case, in the case of what we're doing for class, it does not seem to me that that's something that we particularly need to deal with. But in a larger organization, in your life, if you ever work on this in your professional life, you may need to think about the larger organization architecture and how you would fit into this. We need to think about how our system will be distributed, and we'll spend time talking about what different models of distribution there can be. But basically, how are we going to place our system on different computers, and what relationship will those computers have? Is there a particular style that's appropriate for our system? We talked a little bit about this in the first video, but if you do a web-based retail application, there are certain architectural styles that are appropriate, and we'll talk about that later when we get into the software architecture. Is there a particular way that we need to approach the structure of our system? How are we going to decompose our functions into modules, into those components? And how do we want to document this? We're going to start by looking at some hardware architectures. We are not going to do this for our own project, but I wanted you to see what these kinds of architectures look like. This is a model for a very large storage mechanism, a storage array for a large university. This is for Indiana University. Everyone in the university can use this storage array, and it's distributed in that there are two identical versions of this hardware. You can see it's sort of divided down the center here. So one side is on the Bloomington campus and one is in the Indianapolis campus. And how this works is that you log in to get to the data through these computers. There is a network that takes you to these computers, which manage the writing and accessing of the data. A lot of the data is on disk array. This is a 96 terabyte, although I think it's double that now over the years. This is slightly an older version. But the data gets written to a disk. After a certain amount of time, the data goes from disk to tape if it hasn't been used. Basically it migrates. And these computers manage that process. There's software on these computers that manage that process. And so it goes to the tape drives. And when you need that data again, the data is copied from the tape to the disk so you can access it. This was built because there were, if you remember from our first video, there were certain quality requirements for this storage system. It needed to be available 24/7. There could not be downtime for it. The data that was written on one file, on one storage disk, needed to be copied immediately to the other location so that there would be failover. This is how you can get 24/7 availability, is by having by having duplicate copies available all the time. And so that's how this was developed. And this was, really quite an expensive process and an expensive system. But many businesses do this, many universities do this because of the need for availability of their data. This needed to be available because of the some government contracts for running their supercomputers. And so while they built this, it was available then to the entire organization. So that's a hardware architecture at the big level. At a smaller level, we can also have architectures where we design the use of servers, individual servers or a set of servers. This is talking about how the architecture for a set of virtual machines, which is just a way of dividing up computing resources in a more efficient way, so that you can have lots of applications running in the same hardware environment. But it's just that what I wanted to show is that there's just a different scale, right? So a great big scale, this is a much smaller scale. And yet on a smaller scale is this idea of having a backup architecture. So being able to gather up files, being able to back up, push everything to a backup server that then goes to tape libraries as a way to protect data. Just another version of a hardware architecture. But we're going to spend most of our time talking about software architecture, first of all, because we're doing software design. We're designing a system that will be implemented as software. And so how do we decide which ones of these works really well for our system? We're going to talk about client server, peer-to-peer, distributed, and then a deployment architecture. So client server is the most prevalent architecture for software right now. And it has been for, 20 years. This is the primary, moving from mainframes, which were pretty monolithic, to this client server model happened sometime in the 1990s, middle to late 1990s, and it's the still predominant model today. There are two models within client server. One is called a fat client with a thin server, and the other is a thin client with a fat server. And so what does this mean? A fat client, it means that it's really talking about the distribution of work, right? So the fat part does the most of the work and the thin part does the least amount of work. And the original way that client server was implemented was with a fat client and a thin server. So we had PCs that would run an application under Windows or under the Mac OS, and it was the client based. It was all the software was on the PC, and then the server basically held the database. But everything that actually happened, all the work was actually on your personal computer. And then about sometime in the late 19, maybe early 2000s, thin clients became more prevalent, which is using a web browser. So you've got the web browser, your PC running a web browser does some amount of work, but most of the work is happening on the server. So it still is a client-server model. It's just the distribution of work. It's almost never 50-50. It's always one of the pieces in the client server is doing a little more work than the other. So in general, database servers are thin servers. Web clients are thin clients, and then the server for that, a web server, is basically the fat server. And so it started again pretty in this, the original client server was the fat client on a PC, and a server, the bigger computer the shared computer just held the database. But in the I would say, mid to late 1990s, there came the idea of the client, an application server where most of your logic is, and then the database server. And you might notice that this looks very much like that tiered architecture that we've taught about, the idea of separating your application into tiers. And that was very much based on this idea of client server, that we've got a distribution of some of the software on the client, some of the software in this middle layer, and then the database server. So the client generally handles the user interface. It's generally accessible through the network. The middleware, this is another term that is often used to describe those middle layers. And this can be, as we talked about in the earlier video, this can be multiple layers if necessary. Some people design it as one layer and some as 2 or 3, depends really on the functions that need to happen and the granularity that you need to describe this as. This is software to support the clients, software for dealing with the transactions and the integration with the data itself. And then the server, this is the databases, the groupware, those kinds of things. And this is, we'll look at several examples of this in just a minute. Peer-to-peer is much less frequently used. It is generally used for file sharing kinds of applications. So back in the day, the first application that I know that was really peer-to-peer like this was Napster, which was a file sharing software, and BitTorrent, which you may know, works this way. Every computer is equal on the network. I can get data from any computer and share it that way. And a distributed architecture has many computers, but there's a central computer that is distributing the work. So I have the primary node, and in this example, I can be, my metadata is here, my search server is here, I have an event server, a user server, distributed search, and this works. This is used in a lot of really large systems. Lots of high tech or high volume, big data processing systems work this way because I can share the work amongst a lot of computers. And I do have to have, the problem is that there's a lot of overhead sometimes in the transportation cost between the different systems. So this is used under very specific circumstances, like supercomputers do this kind of thing. internally, and then lots of big data systems work this way when you have to have lots and lots of data. This is an architecture that's showing the deployment architecture. We talked in the first video a little bit about this Koali OLE system. This is an open source library management system. And this is just showing that they're going to have 3 primary computers in their environment. One is for giving demonstrations, one is for their testing environment, and one is for their development environment. And then at some point they would have, this is while they were developing the system, and a production environment. So this is just saying, this is just showing what's going to be laid out on different computers. So when we talk about an application architecture, we are really going to talk about these different structural components, the interface, query management, that is how we're going to ask questions of our database and get answers back, actually managing the data itself, the access control, security, and we can organize our layers in either by conceptually, by function, or by priority. What are we going to be working on first, or what's the most important component? So let's look at how some of that works. This is a client-server software for a small system to create data about library holdings. And so we have a client that talks to an Oracle database. There's data coming from scanners, going through a quality control process that goes into the database. This data gets transported to another system called Fedora. The data gets copied into that mass storage system, and then there's a web browser. So this is the user interface, and then this is the data management process. This is the architecture for something called the Hadi Trust. So the Hadi Trust is the output, is a system that manages the output of the Google Books digitizing process. And so in some ways this looks a little bit like a process model, doesn't it? So and this one as well. This is talking about a data, this is really documenting the flow, this architecture documents the flow of the data between these different components and shows the relationships of the components based on a data flow. And that's one way that we want it. That's the picture, that's the information that this architecture wanted to show. In this architecture, they really want to show the primary components, and then they use arrows. We don't always need to use arrows, but arrows are okay in an architecture. And in this one, they're showing this is the set of functions that deals with ingesting data. So the producer is Google. Google sends the digital images of the books into this component where things are validated. There are URLs are created, metadata is created, and it's packaged up. The metadata comes here where it is dealt with and put into a searchable interface. The data gets indexed this way, it gets stored here, and then there's different management. Now this is based on a set of this architecture shows how they fit 3 existing systems together. So this was a system that already existed, this was a system that already existed, and this was the new system that they built to make all of this work. So they had an existing set of systems, and so this is showing 3 distinct software systems and a big hardware architecture. This is an architecture for something called the HathiTrust Research Center. And this is uses the data from this system, but is a completely different system. So the data gets brought in to this system. But this is a more traditional layered approach. So we have the user interface, where we've got the portal to the system, the web interface to the system. Another component for creating sets of data. We have another layer that controls the sessions. We have security, we have data, and we have something they call a registry. So this is a way for people to be able to choose the functions that they do. And we have 2 views of the same system. I actually prefer this view. I think it's clearer about what happens. So again, we have the user interface at the top. So this system does something really interesting. It has a whole set of functions that it wants to do to allow people to do things like run different statistical analysis against the text of the books from the Google Books Digitizing project. So I might want to be able to do a word count, or I might want to be able to do a content analysis. Anyway, I had to have a way to store those. And so that's what this agent does. This agent just manages all those different functions that can be done. So this is how we can build, this is how we communicate how a system is laid out. And in our next video, we're going to talk about exactly how you can build an architecture for your system. Let me know if you have questions.